Good morning, students. Now we will be discussing the term latent heat, because in chemical industries it is important to convert either solid to liquid form or liquid to solid form or liquid to vapor form or vapor to liquid form. In such cases, it is necessary to know how to calculate the quantity of heat to be supplied or heat to be removed. And this we are discussing into two different cases. One is without phase change and the other is with phase change. So two terms you need to understand very clearly, that is, one is sensible heat and the other is latent heat. So when there is no phase change, that is only when a liquid is to be heated again to liquid only, initially and final stage of both liquid form only, then that term we use is sensible heat. But latent heat term we use when there is phase change. Okay. So sensible heat, till now in the previous classes we have discussed very clearly how to calculate the sensible heat, that is absorbed or that is released. But now we need to understand the term latent heat. Okay. So latent heat term comes only when there is phase change, that is when a solid is converting into a liquid or vice versa, that is liquid to solid, or when a liquid is converting into vapor or a vapor to a liquid. Definitely there should be phase change, then only the term latent heat comes. So what is latent heat? The definition is latent heat is defined as the amount of heat energy that is absorbed or released during a phase change of a substance. That means this phase change can be, that is two. One is solid to liquid. Okay. That means you take the very common example of ice. If we want to convert ice to water, what we need to do? We need to supply heat energy. Okay. If you want to convert ice to water, we need to supply heat energy. Then that much, what amount of heat energy is necessary or required to convert solid to liquid, that is called latent heat of fusion, lambda F. Okay, that is called latent heat of fusion. This is called latent, the heat absorbed or gained. In the same way, if we want to convert the liquid into solid, the same amount of heat is to be removed. That means if you want to freeze water, what we do? We keep it in the freeze, isn't it? There we remove some quantity of heat, then it will become solid. So that is, so this is called latent heat of fusion, lambda F. Lambda F, particularly this term latent heat of fusion, we use for the phase change between solid to liquid. So lambda F of water is 80 calorie per gram. Latent heat of fusion of water is 80 calories per gram. What does it mean? To melt 1 gram of ice, 80 calories are to be supplied. Okay? To melt 1 gram of ice, 80 calories heat content is to be supplied. Then we will get 1 gram of liquid, that is liquid water. In the same way, if you want to condense 1 gram of water, if you want to condense 1 gram of water, you need to remove 80 calories of heat. Then it will become ice. That is the latent heat of fusion. That means you can notice one point, there won't be any temperature change. That means here also 0 degrees centigrade only here. Suppose solid water, if you take example water, this also 0 degrees centigrade centigrade. This is ice. Ice is also at 0 degree centigrade, and water is also at 0 degree centigrade. Please notice this. There won't be any temperature change. But what is changing? Phase is changing. Okay? Temperature is not changing, but phase is changing from solid phase to liquid phase. To convert that solid phase to liquid phase, what amount of heat energy is to be supplied? That is called latent heat of fusion. So, one example value I am writing here. Latent heat of fusion of water 80 calories per gram. That means in order to convert 1 gram of ice into water, which is also at 0 degree centigrade, we need to supply 80 calories. That is called, in the same way reverse process, we need to remove 80 calories if you want to convert 1 gram of water at 0 degrees to ice at 0 degree centigrade. So that is fusion. And here latent heat of vaporization. Here latent heat of vaporization. That is same way we can define the quantity of vaporization, means to become vapor. So the quantity of heat that is to be supplied to the liquid at its boiling point to convert into the vapor. At the same boiling point only, temperature will not change. That is called latent heat of vaporization. Because it is vaporization, it is a lambda V. Okay. So once again, what is the definition of latent heat of vaporization? Lambda V. The quantity of heat to be supplied to convert liquid to vapor at its boiling point. At its boiling point will not change, but only phase is changing from liquid to vapor. And for example, latent heat of vaporization of water is 540 calories per gram, nearly. Okay. So what does it mean? That means to convert 1 gram of water, at boiling point. Okay. To convert 1 gram of water at boiling point to water vapor at boiling point. To water vapor at boiling point. What amount of heat that is to be supplied? That is called latent heat. Okay. Latent heat of vaporization. This is also called enthalpy gained. Enthalpy is nothing but heat content. So during phase change, this is also boiling point, this is also boiling point. Temperature remains constant, but phase is changing from liquid phase to vapor phase. And its units are what? Lambda units. Heat energy per gram. See, in previous classes we have discussed per gram means what? Specific. So it is nothing but we can also say specific latent heat. Okay. Or sometimes you may get the units calories per gram mole also. Depends. Okay. You will get the data as per gram mole or normally per gram. These values are available in literature. So calories per gram or joules per gram or kilojoules per kg and so on. Here also same units. So now we will see a small example. What is how to calculate the quantity of heat energy that is to be supplied. Okay. We take a small example, say water. Suppose you have 1 kg of water, okay? 1 kg of ice. Okay, suppose 1 kg of ice. Example, 1 kg of ice. Consider 1 kg of ice. So, what quantity of heat is to be supplied? What quantity of heat is to be supplied to get water? To get water. 1 kg of ice to water. What quantity of water? So, because the phase change is from ice to water. Okay, this is the phase change. Phase change is from ice to water. At what temperature it takes place? It takes place at freezing point, that is 0 degrees centigrade. Okay, it takes place at 0 degrees centigrade. So, this is also 0 degrees centigrade. This is also 0 degrees centigrade. Okay, ice also at 0 degrees centigrade. Water is also at 0 degrees centigrade. So, what is the quantity of heat energy that is called lambda F? We know that lambda F is nearly 80 calories per gram. Okay, 80 calories per gram. So, therefore, what quantity of heat energy per 1 kg of ice? You have 1 kg of ice. Okay, so Q is equal to, this is the quantity of heat energy to be supplied. Q is nothing but heat energy to be supplied. So, this is what you have lambda F per 1 gram 80 calories. So, lambda F. This is per gram, you know, that is why how many grams are there? 1 kg you have, that is 1000 grams. You convert into 1000 grams. Because this is per gram, here you take a mass you take here. So, 1000 into 80. This is what? Grams. 1000 grams. And this is calories per gram. So, you will get 80,000 calories. Okay. This is latent heat calculation. That means in order to melt 1 kg of ice, that means 1000 grams. Since you have lambda unit in per gram, what quantity of heat is to be supplied? Per 1 gram, 80 calories. So, per 1000 grams, how much? M lambda F, 1000 into 80. Okay. We will see another small example. Say, consider ethanol. What quantity of small problems just to understand the concept. What quantity of heat is to be supplied to produce 1000 kg per hour of ethanol vapor. 1000 kg per hour of ethanol vapor from liquid ethanol at its boiling point. Okay, at its boiling point. So, lambda V, latent heat of vaporization, is given as of ethanol 202 kilocalories per kg. Okay, latent heat lambda V of ethanol, this is given. Okay, like this. So what quantity of heat, second example, what quantity of heat is to be supplied to produce 1000 kg per hour of ethanol vapor? So what is the problem here? Ethanol, liquid ethanol is to be converted to ethanol vapor. Okay, liquid ethanol is to be converted into ethanol vapor. That is the problem. So what is the flow rate here? What weight here? So this is kg per hour. So you can say m dot. I already explained in the previous classes. If it is per hour, we use m dot here. That is the mass flow rate. That is here 1000 kg per hour. Same amount. We have taken 1000 kg per hour of liquid and we are supplying heat, and that 1000 kg is converting into ethanol vapor. Again 1000 kg mass is not changing, but heat content, what about heat content? Heat content is to be supplied and the temperature will not change. This is at boiling point and this is also at boiling point. Okay, this is also at boiling point. Temperature will not change. So what is lambda V here? 202. Therefore the quantity of heat supplied is m dot into lambda V. That is 1000 into lambda V is 202. This is kg per hour and this is kilocalorie per kg. Okay, kg will get cancelled. That is 1000 kilocalories. Since we are taking this is per hour, here also you will have a per hour. Okay, this is the heat to be supplied. Heat to be supplied. Okay. So in this problem we understood very clearly that in order to convert liquid ethanol of 1000 kg per hour into ethanol vapor, what quantity of heat is to be supplied? Since initially also same temperature, boiling point, finally also boiling point, temperature is not changing but phase is changing from liquid phase to vapor phase. In such case, Q is equal to m dot lambda V, because mass flow rate is given here. So m dot we are taking. So this much heat is to be supplied in order to carry out this task. Okay. So this is latent heat. So what I understand by this latent heat, what is the concluding point here? What is the concluding point in when you are using the term latent heat? Then temperature remains constant but phase changes. Okay, but phase changes. That is latent heat. Actually latent heat means the meaning of latent heat is hidden itself. So the heat, the hidden amount of heat. Why we are using the term hidden is small illustration. We will see. Suppose you take water here. Water. This is at 100 degrees centigrade. Water is at 100 degrees centigrade. Now, supply heat. Then what happens? Water vapor will form. Okay? Water vapor will form. Water vapor will form. Now, you supplying heat here. Suppose you are supplying heat. All the heat you are supplying will be utilized only to convert all this liquid into vapor. That is, so there won't be any change in this temperature at 100 only. Vapor also at 100. So liquid also at 100, vapor also at 100. Phase is changing, but temperature is remaining constant. That is latent heat. Okay. Suppose here you take another example of water at 30 degrees centigrade. That is water present at normal room temperature. Then supply heat. Supply heat. What happens? If you supply heat, what happens? You keep a thermometer here. Okay. Keep a thermometer. Then what happens? It shows the rise in temperature slowly because we are supplying heat. It shows the rise in temperature. It may rise to say first to 50 degrees centigrade and then 60 degrees centigrade, then 80 degrees and so on. 99 degrees centigrade, like that, no? It raises its, this thermometer shows you that. So the temperature of water will go on increase. We understand that it is getting heated and its temperature is increasing. And finally it will reach 100 degrees centigrade, which is its boiling point. Which is its boiling point. You are supplying heat, temperature is increasing and increase it to 100 degrees centigrade. Now still supply heat. Continue. Continue supply. Continue supply heat. What happens? You will not find any change in the 100 degrees centigrade. Okay. Then what happens? You are supplying heat, but this thermometer will not show you any rise in the temperature. Remains 100. Then what is happening to that amount of heat we are supplying? Okay. Till now, we are supplying heat, and that is showing in the increase of the temperature. But after reaching 100 degrees centigrade, thermometer value remains constant. It will not show any increase in temperature. But still we are supplying heat. Then what is happening to that heat? That amount of heat what we are supplying after reaching 100 degrees centigrade will be utilized in converting water to water vapor. Okay. That is why it is called hidden heat. Thermometer is not showing the increase in the temperature, but we are supplying heat. Then what is happening to that heat? That heat is utilized in converting water to water vapor. Okay. So this is called latent heat, lambda. Okay. Till now, this is what? Sensible heat. Okay. This is called sensible heat. Amount of heat. Temperature is changing, but phase is not changing. Inverse. Okay. Here, after reaching 100, temperature remains constant. Here comes the term latent heat. Okay. Thank you.